Thanks, guys. I'm in England, missing you, but eating tons of chocolate. Woo! So this is my wife's parents' house, and so we're here visiting with Jim Midgley. And there we go. Yeah. There's our wedding pictures on the wall. Whoa, sick. That's sick. So thanks for special shout out to 5th period who requested this extra video, because I wasn't able to do 2.6 and 2.7 before I left with you guys. But if you know anybody in my other period classes, so 1st and 2nd period, then you can definitely ask them. But I think this video will help you a lot too. So this is like the notes that we did before I left for 1st and 2nd period. And so it's called Symmetry and Behavior. So this will be 2.6. So I'm going to be doing it with my mouse, so I already apologize if it's not looking very good. Right? Okay, so function is even if it's reflected or mirrored about the y-axis. Also a function is a even degree function if the end behavior is both going down down or up up, because that means they're both evenly going in the same direction, right? So that means like this could be x squared, or maybe even negative because it's going down. You could also have x to the 4th power, x to the 6th power. So if you see in the equation the highest power, which is called the degree, then if it's even, then it goes like this, down, down, or up, up. If it's odd, then it goes opposite directions. So a function is odd if it's rotated about the origin by 180 degrees. And so there's a difference between an even function and even degree, an odd degree function and an odd degree, or a neither function, right? Neither function. But you're not going to have to necessarily this year know that on the test. But just to give you an example, so if it doesn't go through the origin, something like this, right? Then everything's going to reflect and go this way. And so this would actually be an odd function because it goes, no, an odd degree function polynomial, because it goes in opposite directions like that and that. But because it doesn't, it's not, what does it say? A function is odd if it's rotated about the origin of 180 degrees. So if we were going to rotate this, it would not look like the original. It would not rotate around the origin, basically. So this one's going to be an odd degree function, and it's also going to be called a neither function because it's neither odd nor even. I mean, it is odd degree, but it's neither function. But really, you're not going to have to worry about that for now. So what are you going to have to worry about is deciding whether something's odd or even. So this is going to be example Lorraine, my wife, who at the moment is trying to get so many things done before we have to return. And so we're going to say that she's always going in opposite directions. And that means that she is an odd, right? An odd function. Can you tell what this one is? Well, this one is symmetric about the y-axis and both going upwards. So we're going to guess that it's maybe like x to the 4th power would be a good guess, because they're both going in the same direction, so it's going to be even. And then we know we have a bunch of stuff after that you have to kind of toy around with. But when graphing these, but basically that's an even function. And but it's also an even degree function. So this is actually odd degree. Again, because it's going in opposite directions, right? Because their ends are going in opposite directions. Sorry, it's hard to write with the mouse, okay? Stop making fun of me, man. So because they go in opposite directions, then it's definitely going to be an odd degree, because it goes down and goes up. Now if this one is going in the same direction, which it is going in the same direction, this would be called an even degree. So even if you didn't know if it was x squared or x to the 6th power or x cubed, so you can what's the phrase? Odd or even degree, and going opposite directions. And so, yeah. So it's x to the 6th, x to the 4th, and it's even degree because it's the power is even. Cool. So then, let's see here. So there's a couple more graphs down here. So again, because this one's going in opposite directions, this would be the odd degree function, because they're going in opposite directions. And then this one is actually going in the same direction. Guess it depends on where you stop, huh? And so this would be going in the same direction, so it's even degree. So hopefully that kind of makes sense so far. But we'll go ahead and do more. Let's do more. How about just looking at the equation really quick? So algebraically, this is how you tell if it's an even or odd function or an either function. But we're not going to necessarily go into detail this year about those ones. Okay, so since the 2 is even, it's an even degree polynomial. Which means it probably, and it's negative in front, which means it's probably going to go down, down. Right? Because it's it's an even function that's negative, so both going down. Now this one is odd, 2x cubed is odd, and so this one is actually an odd degree function. That is not how you spell odd degree. It might have spelled it differently. Okay, so this is an odd degree function. The above is an even degree function. Again, we're going for the highest power or the degree, which is 3. And 3 is an odd degree number, odd degree polynomial. Cool. So we'll try a harder one. So technically this is an either function, algebraically, as well as rotating about the origin, or axis. But because of the 3 there, we'll just go ahead and just like wham bam, we got this. So it's going to be an odd function for sure. It's going in opposite directions. Cool. Okay, finish up our notes next. Polynomial function is a function of the form a n to the x n power all the way to a x to the 0 power, which is just 1. The coefficients are these a positions, and a to the n power is called the leading coefficient. Okay, so this is what we filled out in class. Oh yeah, see what? It says 7:24, but it's actually 7:30 or 2:30 in the morning. Okay, so degree again. What's the degree? It's the you're worth it. It's the highest degree. It's the highest power. So this will be a 5. This one will be a 4. Let's see. This one will be a 3. 2, 1, 0. Now the reason why this last one is 0 is because this is probably like 4x to the 0 power, is what we'll say. So the leading coefficient is what's in front. So that's a 4. This is a -5. Can you tell me what the next one is? You say it behind the screen. What's the next one? Go to the highest degree, and it's the leading coefficient that's in front. So it's just going to be a 12, then -1, and then this one is a -3. Notice the -1 is invisible. It's right there. You can't really see it, but it's an invisible -1. And then nx to the 5th power is just 5th power. No, Newbold. This is called the leading coefficient, which leaves the powers alone. But what it does do is you have to go to the one with the highest power, and then you have to do the leading coefficient. So in this case, it's a +9. Nice. So last but not least, even, odd, or neither degree, or just even or odd degree. So I guess because if you go to the 0 power, it's just a 1, which is a straight line. Then maybe straight line. Oh yeah, it's even. Okay, so this is even. The reason why this next one is odd is because that's to the first power, and then that's even. So we'll put the second power as even. In this case, it was odd, because x to the first power is odd. Then we have x to the third power, even though it's a negative leading coefficient. It is still an odd degree. Make sure you include the word degree to get it right, Newbold. Sorry. So there's going to be an odd degree function. Can I make it sense? So the next one is 3x to the fourth power, so that's even. And the next one after that is x to the fifth power, which sometimes demotes. Whatever. I'm tired. We got this. Odd. So even, odd, even, odd. Again, so the degree is the highest power. If I had any strength to write that down, degree is the highest power, and then looking and deciding if it's even, odd, or odd. Nice, nice. Okay, so we're actually going to go and do the end behavior now, right? So for all of these, all 6 of these on the very bottom of your guided notes there. So as x goes to the left, which we're going to go ahead and denote it by negative infinity. You're always going to do left and right, left and right. So as y goes to negative infinity, x will go to blank. As I was supposed to do y, sorry. So that's a y, there we go. Okay, so then as x goes to the right, positive infinity, y goes to blank. So this is the full part here of doing end behavior, is that you get somebody, there we go. Okay, so when it's saying left, that's negative infinity, right? Because you're going to the left forever and ever and ever, amen. Then we're going to the right to positive infinity, you're going forever and ever and ever and ever and ever. And so we'll just call that going to the right. And so we got 2 answers going on there. Cool. So that means left if it's positive infinity, and that means right if it's negative infinity. Okay, so here we go. So we're going to look at the leading coefficient as well as the power. So 4x to the fourth power, right? That 4 for the power does mean that's an even degree polynomial. And then even degree polynomial. And so remember, going from left to right, going from left to right. Okay, so here's the strategy as we go left to the negative infinity. They're both even, and they're both positive. What does that mean? So that just means it's both going to be ending positive, positive. Because they're both even, and they're both leading coefficients positive. So it's going to go ahead and be y goes to negative infinity, and y goes to negative infinity. Nice. Let's try another one. Okay, and then we'll jump to some homework problems, or maybe some more of these problems. So we got to x, as x approaches negative infinity. We want to know the end behavior. Y goes to blank. It's either going to be negative or positive infinity. As x goes to the left, negative infinity, y goes to blank. As x goes to the right, positive infinity, y goes to blank. Cool. So let's fill in these blanks. Okay, so now we're looking at a negative x squared. So that means that we are going to go ahead and go down like this, because it's a negative x squared. And so that just means what? As x goes to the left, negative infinity, y goes to negative infinity. As x goes to the right, positive infinity, y goes to positive infinity. And there you have it. There we go. Cool. Okay, so the next one, end behavior again. You'll see this on Canvas. So as x goes to, again, this is just the same thing every single time. As x goes to the left, negative infinity. X goes to the right, positive infinity. Cool. So now this one is actually going to be an odd function. It's going to end up like that. Isn't that crazy? That's cray-cray. I don't know my calculator. I'll take a graph and show it to you. Okay, so as x goes to the left, negative infinity, forever to the left. What is y doing? As x goes to the right, forever and ever. What is... Ooh. Thought I heard a dog or something then. That's crazy. Stop hearing things, Newbold. You're freaking me out. I'm freaking myself out, okay? Because it's 2:30 in the morning. I just thought I heard a dog sound. Okay, as x goes to the left, negative infinity. Y goes to blank. As x goes to the right, positive infinity. Y goes to blank. She also ordered some stuff for us while we were there. Then she ran out, maybe. Okay. So as x goes to the left, negative infinity. This is odd. So as we go to the left, it's going to be down here at infinity. We call that what? Negative infinity. As x goes to the right, positive infinity. What is y going to do? So y is going to go up to positive infinity. And there you have it. Negative goes to negative, positive goes to positive. That's x cubed. What if it's a negative x cubed? Well, if it's negative, that means that it's just going to go... Let's let your granddad do it. Okay. So negative x to the third power. Right. So that means we're actually going to start off high and come down low. The only reason why I know that is I plugged it into Desmos or my graphing calculator, and I got a different graph, so I had to retry again. So again, here we go. As x goes to the right, no, left, negative infinity. Okay. So as x goes to the left, negative infinity. Again, it's going to be, so this is the original. Now we're going to switch it, so it's going to go like that. Whoa, craziness. So as x goes to the left, negative infinity. Y goes to what? We'll put a blank there. A little bit nervous about that one. As x goes to the right, positive infinity. Y goes to blank. Okay, so now we're actually going to solve this problem. So as x goes to the left, negative infinity, y goes to blank. As x goes to the right, positive infinity, y goes to blank. So as x goes to the left, you're actually going to start off high, right? Because you're going to finish off at negative, lower than low. And so let's see, as x goes to the left, negative infinity, y goes to positive infinity. As x goes to the right, positive infinity, y is actually going to go to negative infinity. Wait, let me double check. Yes. I think it could just be regular, actually. Evil. Bam. Okay, so as x goes to the left, negative infinity, y goes to positive infinity. As x goes to the right, positive infinity, y goes to the right. Okay, let's see here. Remember, only 2:30 in the morning. Okay, let's try those two on your own. Night fever, night fever. Is this negative x cubed? Or maybe negative x to the fifth power? Start off high, finish low. Wah, 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 wah. Remind me to show this to you in class because it's funny. Okay, excellent. We'll skip that for now. Okay, so I'm actually going to choose a function that I came up with, or I was going to have you come up with it actually as a class. And I don't know if I could find which one it is even. Oh well. Okay, so we're going to go to the far right like this. One. And so we're now going to go and teach you. That was in behavior. That was behavior. We're actually going to do the 2.6, which is like the multiplicity part. And so I want you to get out a blank sheet of paper so you can take some good notes on this, help you ace it on the test. So 2.6, this is the multiplicity part. So I want you to shout out some numbers between, I don't know, like 1 and 6 maybe. maybe in between 1 and 4 actually. So we're going to do y equals x minus 4 Okay, 2.6 multiplicity part, multiplicity part. Nice. Okay, so then what if we have this factor, and we have this factor, and let's see if we have another factor. In fact, I think this time we're gonna let you guys choose it. So you behind the screen, do you want 4, 3, 2? Is that okay? Do you want a different one? What, do you want to make that positive? Okay, fine. So definitely going to make that positive. Nice. Okay, now multiplicity part is the power in front, or the power at the end. So if this is x minus 4 to the first power, this is x plus 3 to the last power, and x plus 3 in the middle. But yeah. Okay, and then I'll put a squared there. Cool. Okay, so basically this is how it rolls. So we're doing multiplicity. I think the first step on there is going to ask you for the leading term. And so the leading term has to do with the x term in front. So x to the first power times x to the first power. And then times... No, this is going to be the second power now. So that means this is actually going to be a 2, and you'll see that later on. Okay. We have 1, 1, 2s are multiplicities. So again, leading behavior is going to be x to the first times x to the first times x squared, and that's it. So x to the first times x to the first. Just grabbing it directly from the formula up there. Cool. Okay, so that means that our leading term is going to be x to the 4th power. Nice, nice. And then now it's lunchtime. Next question. So it's going to ask for r for roots. So what's the roots on this function that we gave you? And what's the multiplicities? So the roots here we're going to grab is that negative 4. And so it's actually going to become a positive 4. Excellent. Whoa, what just happened? I fell asleep. Okay, so we have a root at 4. Root at not negative 4, but a positive 4. And then the multiplicity of just 1. And that's going to ask for the next one. And so the next one, roots or none, tell us that. So the next root is a 4. The next root will be negative 3, right? As our root, negative 3. Then we will look at the next root. So it's going to be opposite. So not a positive 3, but a negative 3 with a multiplicity of 1. Multiplicity of 1. Okay, last but not least, we have a multiplicity of 2 for the root. Not a positive 2, but you guessed it. So it's going to be a root is going to be a negative 2. And then the multiplicity is actually going to be a 2. Multiplicity is going to be a 2. And so we'll talk more about that in the future. Last but not least, after you do the leading term, which is x to the 4th power, and you find each of the roots, boom, 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 and then you do like the multiplicities with the powers on top. Cool. So that's basically 2.6. I know you need to factor by grouping, stuff like that. But email me if you want more help with that factoring part. And I can help you. Remember, I did a bunch of the problems on the homework. So, but making this video for you as well. Okay, so then we'll probably wrap this up for that's 2.6 multiplicity and behavior. Oh, so the y-intercept, right? So that's last but not least when we're graphing these. Or at least trying to identify parts of them so they're ready for all the driving. Okay, what did I just say? All the driving. What am I talking about? Sorry, I was falling asleep. Okay, so y-intercept is basically taking each of the roots, like basically you're setting x equal to 0. To find the y-intercept, you set x equals 0. And so when you do that, that means that all these will zero out, and you'll be left with whatever's left. Okay, so set x equals 0. So the that's supposed to be the y-intercept. Wow, Newbold, wow, sorry, it's early. Okay, so that's y-intercept. So we're going to take each of those zeros and just multiply them. That's going to give us our y-intercept. And you can graph it as well in Desmos and check it out because that's also on there too. Okay, so then what are we doing? We're multiplying exactly how we see it. So negative 4 to the first power times, we have a 3 to the first power next. Good. And then last but not least, so we have negative 4 times negative 3 times 2 squared. So then you're just going to multiply all that out. So negative 4 times negative 3 is a positive 12. 2 squared is 4. So that's going to be 12, 12, 24, 24, 24, 48. So we're going to have a y-intercept of 48 for this randomly chose problem that we just made. Sick. So that's the y-intercept. Okay, I'll do one more quick video for 2.7. Thanks for watching. You behind the screen. Thanks for watching. Wake up, Newbo. England. It's a miracle. Tell you about it later.